In this video, we're going to do some examples of applications of percents, and these examples take more than one step to solve. These are all real-life examples and probably situations that you'll run into in your life or have already run into. This first situation is very common. We have a sweater that has a regular price of $44 and it's on sale for 20% off. What is the sale price of the sweater? So the first thing that we'd probably want to figure out is how much that we're going to save. And we know it's 20% off. What is it 20% off of? It is 20% off of the regular price. Now remember, when you're dealing with percents and you have 20% of something, that of is going to mean multiply. So what we need to do to figure out how much we're going to save is take 20% times $40. Now I'll use an X for times, that's fine. Now, if you've gone through the videos or probably in your life learned how to do these kind of percents in your head, I think that's great. Oops, I wrote $40. Let's change that to 44. Especially something like 20%, that's really a problem that would be good to know how to do in your head. And I do have a video on doing percents mentally, so if you haven't seen that, you might want to go see that in the percents playlist. So let's just do that. Let's do it without using mental math this first time, and then let's go back and review how to do that. So when you're taking a percent and multiplying it by something, you need to change it into its decimal form. Now 20% means per hundred. That's what percent means, per hundred. So when we change this to a decimal, we want to think of this as 20/100ths, and 20/100ths is written 0.20. Now you may have heard before to move your decimal 2 places, and that is exactly right. So in the percent, the decimal's here, and we move it 2 places to the left to come up with the decimal form. I think it's good to review why, though. And the reason why, again, is because percent means per hundred, and 0.20 is 20/100ths. So you're converting that percent to a decimal. So now we're going to multiply 0.2 times 44. So we'll go over here and do that, just kind of writing it out the long way here. Now notice I dropped the 0 on the end. That's because it doesn't mean anything in this case. If you have zeros on the far right side of your decimal, they don't hold any value there. Alright, so 4 times 2 is 8, and still 4 times 2 is 8, and I have one place to the right of my decimal in my numbers, so therefore I'm going to move my decimal one place this way, and I end up with 8.8. Now with any of these percent problems, you should look at your answer and ask yourself, does that make sense? So I've got $8.80. Now notice I put a 0 back on there because I'm talking about money. My answer is 8.8, but I'm asking how much do I save, and in money that's $8.80. So depending on the application, you may want to add a 0 in this case to represent 80 cents. Now does that make sense? $8.80. $44 sweater on sale, 20% off. Does it make sense we'd save about $8.80? That seems pretty reasonable. Alright, so if we were going to do this $8.80 in our head, let's do that. Let's pretend like we remember how to do this in our head. So the big thing to remember is when you're doing 10%, you just move the decimal one place. So if I want to find 10% of 44, I just take 44 and I move the decimal in 44 one place to the left, and I get 4.4. So 10% would be $4.40. So 20% would just be double that, $8.80, which is what we got when we multiplied it out. I'll say the long way, although it didn't take that long. That's a good review. You should know how to do 20% in your head. Alright, well, it did ask us what is the sale price. This $8.80 we figured out was just how much we'll save. So what's the sale price? Hopefully you're saying, well, we need to subtract off $8.80. Alright, so I'm going to put a decimal after my 44 and some zeros so I can subtract. I'm going to have to borrow. And you guys should probably be doing this on your own, just to practice. So we end up with $35.20 for our answer. And that's generally how you're going to see that done. Now, at the risk of showing you too many different ways to do something, I would like to show you a little shortcut for this. If you're getting 20% off of the sweater, that means you're paying 80% of the price. If you think of the whole entire sweater as 100% of the cost and you're getting 20% off, well, that means you have to pay 80% of the price. That's what you have to pay. So if we took $44 and multiplied it by 80%, that would be how much we'd have to pay. So 4 times 8 is 32. Carry the 3. 4 times 8 is still 32. Plus 3 is 35. And then I have one number to the right of the decimal, so I move my decimal one place. And look at that. I end up with $35.20. So if you subtract off the percent from 100% at the beginning and then multiply by that, you get the sale price. Hopefully you're seeing that in the first case we found how much we would save and then we subtracted it off, and in the second case we subtracted the percent from 100% and then multiplied it and got directly to the sale price. But either way will work, so you do it whichever way that you're comfortable with. Alright, let's look at the next example. This is kind of an opposite situation here. We have the population of Funville is 25,400 and it's expected to increase by 12% next year. What is the expected population of Funville next year? So the sweater problem, we had a price and it decreased. Well, in this problem we have a population that's expected to increase by 12%. Again, I can't emphasize enough, when you're dealing with a percent, you should always ask yourself of what? What is this a percent of? This is a percent of the population. The population of Funville is 25,400 and it's expected to increase by 12%. 12% of the current population. So in order to figure out how much the population is going to increase, we need to multiply the population by 12%. And you may recall a formula from previous videos: the whole times the percent equals the part. And we're really using this formula. In this case, the whole is the whole population times the percent of increase is going to be the part, which is going to be the number of people that we expect to move to Funville next year. Alright, so to multiply this, we need to change 12% to a decimal number. Hopefully you know what that is, or you're thinking of it. 12%, 12 per hundred, 12 hundredths is 0.12. Let's move the decimal 2 places, 1, 2, like that. And we'll do the multiplication. Now, depending on what you're studying this for and what your teacher requires, or the test requires, you may be able to use a calculator. For this problem, I'll go ahead and do it out long way, and then the next problem we'll use a calculator just to save time. Alright, so we have 0, 0, 8, 10, carry the 1 is 5, and then we add a 0, and we have 1 times 0, 1 times 0, 1 times 4, 1 times 5, 1 times 2. Multiplication isn't too hard with 2's and 1's. And then we add it all up, carry the 1, 3. Now, the number of places we're going to move our decimal is 2, because we have 2 digits to the right of the decimal. So we're going to move it 2 places from the end. And now we're dealing with people. So these zeros really don't mean anything at the end. We can simplify this to 3,048 people. Alright, have we answered the question? What is the expected population of Funville next year? We haven't quite answered the question. This isn't the expected population. The population right now is 25,000, over 25,000, and it's going to increase by 12% next year. So this is the amount of increase. This is how many people are expected to move into Funville. In order to find the final answer, we need to add those people into our current population and see how many Fun residents we're going to have next year. Looks like 28,448 people. So just like the sweater problem, with the sweater problem, we found the amount that we would save and we subtracted it off. If something's increasing, you find the amount, how much it's going to go up, and then you add it in. It's the same kind of situation. And there is a shortcut to this situation as well, like we did the 80% on the sweater. The shortcut for this would be, right now you have a population, say it's 100%, and it's going to increase by 12%. So that's 112%. So in a decimal, 112% would be 1.12. Now if we took that number and multiplied it by our population, 112% of our population, let me pull out the calculator to do that, 1.12 times 25,400 equals 28,448 people. So again, you're adding the percent and then multiplying it by the population. That will work as well. Whatever way you like. Okay, next one. Got a couple more examples here. Let's see. This one uses a common formula. Eliza puts $550 in a savings account that pays 3.5% annual simple interest. And here's the formula you need. Interest equals principal times rate times time. The principal is how much that they invest. So in that case, that's the $550. The principal is the amount you put in the bank. The rate is the percent. And the time is in years. And that's because the rate is usually an annual percentage rate. Now, interest problems can get much more complicated than this, but this is the basic formula behind even the most complicated interest problem. So it's good to know this formula. How much will she have in her account in 2 years? So we're going to follow this formula. Interest equals principal times rate times time. I'm going to abbreviate this. This is common as well when you're working with formulas. Interest equals principal times rate times time. Now when I don't put any symbols between the letters, it means to multiply. And you may not have seen that before, so if you're more comfortable putting a little times in there for your formula, that's fine. But it's common that if you don't put any symbols between your letters, it means to multiply those values. Let's see, where are we at? Now, just to make sure everybody understands what interest is the money that the bank gives you if you put money in there. It's also the amount that you have to pay if you borrow money. This is the same formula if you borrow money, and in that case the principal would be how much you owe times the rate times the time that you're borrowing it for, usually a month. And so if it's a month, you would put 1/12 in there for your years, because a month is 1/12 of a year. And you may see that on a credit card statement or a loan statement, so that's kind of good to know. Alright, so in this case though, we're going to get interest, we're not going to pay interest. How much interest are we going to earn? That's what we're trying to figure out. Well, we take the principal, which is how much Eliza put in the bank, which is $550, times the rate, which is 3.5%, times the time in years, which is 2 years. So that's all we have to do. It's a pretty straightforward problem. We're just going to multiply these things together. Now, when we write 3.5% as a decimal, we're going to move the decimal 2 places to the left. So we're going to get 0.035. So the decimal was here between the 3 and the 5, and we went 1, 2. So we have to add a 0 in there to hold that place. Let's use the calculator to figure this one out. 550 times 0.035 times 2 equals 38.5. In money, that would be $38.50. Now the question asks, how much will she have in her account? Remember, she had $550 in her account to start, and then she earned this much interest. So you would want to add that $550 in with the interest. If the question asked how much interest did she earn, then we could just stop at the $38.50. But it didn't. It asked how much she'd have in her account, and that would be $588.50. Part B says, how much would she have in her account in 6 months? So what if she only left it in there for 6 months? Well, the principal would still be $550. The rate would still be 3.5%, 0.035. I'm going to run out of room. But now, 6 months, that's not even a whole year. And we can't put a 6 here. If we put a 6 here, it's going to mean 6 years. We have to think of how much of a year this is, 6 months. What part of a year is that? Hopefully you've come up with 1/2. It's 1/2 of a year. 6 months is 1/2 of a year. So to multiply this out using a calculator, we have a couple different options. You probably know that 1/2 is 0.5, so we can just do 550 times 0.035 times 0.5 for a half. And we get $9, and we get 0.625. So let's talk about that. 9.625. Interest equals 9.625. Now we're talking about money, so we need to round to the nearest penny. We're going to cut that off there, and that 5 is going to round that 2 up to a 3. I'll tell you, in practical situations at a bank, I'm not sure that they would round that up. It probably depends on the bank and how they have their software program to deal with these kind of situations when you have fractions of pennies. But it wouldn't surprise me at all if they cut that 5 off and kept that half a penny for themselves. But for our purposes, we'll go ahead and use the rules of rounding and round that up to $9.63. But if you look at your bank statement and see that penny missing, they may not like rounding. All right, so now we need to figure out how much she'd have in her account. So we'll just add in the $550, and we'll get $559.63. There is another way to do this on the calculator. If you didn't know that 1/2 was 0.5, you could punch in 550 times 0.035, and then times by 1 and divide by 2. Remember that fraction bar means divide. So times 1 divided by 2 equals, and you get the same answer. Some of you might be saying, times by 1, why would I do that? That doesn't change anything. Well, I just want to show you because it might not always be a 1 on the top. If it was multiplying by, if it was 5 months, it would be 5 over 12. So you'd multiply by 5 and divide by 12. In other words, when you're multiplying by a fraction, you can always multiply by the top number and divide by the bottom number when you're using your calculator. So that is simple interest, another application of percents. Let's look at one more example. A multi-step problem, but a very familiar situation. A couple went to a restaurant and each ordered dinner. They were priced at $14.95 and $12.95. They also ordered beverages that cost $1.95 and $4.95. They have a coupon for 10% off the cost of the meal, and the tax rate is 8.7%. Now, when we say the cost of the meal, that's the total cost, so that includes the beverages as well. All right, part A, what is the cost of the meal before the discount? And that's probably what you were thinking when you were reading this as well. The first thing I'm going to have to do is add all this up and figure out what their food bill was. So we had $14.95, $12.95, $1.95, and $4.95. And you could obviously line all these decimals up and add everything together. Wouldn't be too bad. Actually, a good way would be to estimate it and round it up to the nearest dollar and subtract off some nickels, but we'll just do it this way. So it looks like $34.80 for the cost of the meal. $34.80. I was talking while I was doing that. Let's practice estimating and make sure I've got that right. So this is close to $15. This is close to $13. 2 and 5, so that would be, if we added these up, that'd be 28, 30, 35, but each of these is down a nickel. See how we rounded up a nickel each time? So this adds up to 35, but I'm short 4 nickels here, so if I take 35 bucks and subtract off 4 nickels, which is 20 cents, I'm going to end up with $34.80. Okay, I'm confident then we have the right answer for that. Cost of the meal before the discount, $34.80. Part B, what is the cost of the meal after the discount? Well, we have a coupon for 10% off. Now, the tax isn't going to come till the end. If you think about it, it wouldn't be fair for them, for the restaurant to charge tax on this $34.80. They're going to subtract off the 10% that the couple saves and then figure out the tax on that. And it makes a difference. If you'd calculate 8.7% of $34, there's going to be more tax than if you wait and calculate the tax after you subtract off the 10%. So it makes a difference when you do the tax. And that's really the big point of this problem, is what you multiply your percent by is very important, and we need to pay attention to that. So our 10% off, and like I said earlier, 10% off of what? Of the cost of the meal. So we need to multiply this by 10%. Remember, this is one we can do in our head. All you have to do to multiply by 10% is to move the decimal one place over, so it's 3.48. I mean, if you want to get out the calculator and do that, you can, but this is really something that you should memorize, how to multiply 10% in your head. 4.8 times 10%, which is 0.1. 348. I mean, that's something you need to know, and don't waste your time with your calculator when you're doing 10%. So this is how much we're going to save. So we have to do one more thing here to figure out the cost of the meal. We have to subtract off that $3.48 and see how much we get here. So let's borrow, end up with a 2, 3, 1. So it looks like $31.32 is the cost of the meal after the discount. Just to reiterate what I was saying earlier with the sweater, and I'm kind of laughing because there's always so many different ways to do a math problem, and as an instructor you wonder, how many ways should I show? I don't want to confuse people. But a shortcut to this, if we save 10%, what percent would we have to pay? If we save 10% on the meal, what percent would we pay? We would pay 90%. Remember earlier when we were taking 100% and subtracting stuff off? So if I would have taken $34.80 and multiplied it by 0.9 for 90%, that would take me straight to the $31.32, the cost of the meal after the discount. So just remember that. That's a good little shortcut. But you can see either way works. All right, part C. Almost done. So now we need to figure out the tax. All right, so we got $31.32, and we have to pay a tax of 8.7%. We're going to move our decimal 2 places this way. 8.7% then would be 0.087. So if we multiply this by 0.087, we'll figure out how much tax we have to pay. 3132 times 0.087 equals, let's round that to the nearest penny. That would be $2.72, because that 4 after the 2 is not going to round the 2 up. So $2.72. Oops. $2.72, that's the tax. And now we need to add that into the cost of the meal, which was $31.32. We can do this without a calculator. 4. Looks like $34.04 would be the total cost of the meal. Again, with this 8.7% with the tax, if you think of that as taking what you have to pay as 100%, and then you're adding 8.7%, you're having to pay 108.7%. I'm running out of room here. I'm going to get rid of this waiter. See you, waiter. So a quick way, a little quicker way to get to this answer, instead of figuring out the tax and then adding it in, you could just take this 108.7%, which in a decimal is 1.087, and multiply that by the cost of your meal of $31.32, and that should give us $34.04. Let's check it out. 31.32 times 1.087 equals 3404. So you could do it, you know, whichever way you like. I think the first way that we did it is probably the most intuitive way. Figure out the tax and then add it in. But if you're comfortable with this shortcut, it's a good thing to know. Same thing over here on part B. Figure out the discount and then subtract it. I hope all these examples helped you, and really, you know, keep an eye out in the real world for when you're dealing with percents, and practice them, because they're one thing in math that seem to constantly show up throughout your life, and you never have to ask the question, when am I going to have to use this when it comes to percents?